This
Thursday
one,
also can.
say
We, we
again.
just we just do replacement classes for Thursday.
We do what?
Replacement classes for Thursday.
Then I still owe you another 40 minutes. Oh, okay.
Can also. Okay.
We should, we would, this one just to summarize for you lah, what we will cover lah. Right? Is you have to memorize these two. You have to memorize that there's the number of mole, and then we will derive this equation. We derive this equation from this one from Newton's law lah. Actually, Newton's law of motion. We will derive this equation lah, and then from these two equation, we will derive this equation lah. Okay, that's your syllabus. Okay, we try to understand real gas by dealing with ideal gas. A simplified model. It helps us to understand better the thing of gas as particle. And it helps us to understand the ideal gas law. Right? The definition. Right? Or you might want to use the syllabus. Right? That definition given by the syllabus. 1 mole of any substance is the amount containing a number of particles of that substance equal to Avogadro's constant, or atoms in 12 grams of carbon 12. Right? Can follow the syllabus. Because they will mark it according to syllabus. Avogadro's constant is the number of atoms in 0.012 kilogram of carbon 12. Right? This one is given in the data sheet, this number. If there are n molecules in a container, then the number of mole is just the formula, n divided by Na. Molar mass is defined as the mass of 1 mole of the substance. Unit is gram per mole or kilogram per mole. Example of carbon 12 is 12 grams per mole. So if we have m kilogram of substance of molar mass mr, then the number of mole is just m over mr. Okay, so it's very straightforward lah. 15.1, just definition and the formula. Right? You can find the formula in your data sheet. R is given. K is Boltzmann's constant. We will show you how are these two related. And this is also the formula given. Okay, so let's go to do some example. Worksheet 15, page 68. Try this one. 12 grams of carbon contains 6.02 times 10 to the power 3 atoms. Calculate the mass of one atom of carbon 12. Right? 602 atoms has a mass of 12 grams. The mass of one atom, 12 grams, divided by that number of atoms. You get that. The average mass of nucleon, right? There are nucleon, and this is atomic mass unit lah. Nucleon is just a particle found in the nucleus. It can be a neutron, it can be a proton. Right? It's a general term for neutron and proton. A nucleon is a particle found in the nucleus, namely proton or neutron. So there are 12 nucleons in carbon 12. in the nucleus, the mass of nucleon is that. We will calculate this in nuclear physics. It's just to get you ready for it. Okay or not? Any comment? It's called atomic mass unit. Okay, number 2. Calculate the number of atoms in 0.3 gram of lithium and the number of mole of lithium. Can get the answer? Okay, basically using the formula, that's all. 7 gram of lithium contains 6.02 times 10 to the power 23 atoms. So 0.3 gram contains, let's use this formula. 0.3 divided by 7 times your 0.62 times 10 to the power 23, the number of atoms. Number of mole. 1 mole of lithium has 7 grams. The number of mole is 0.3 divided by 7, this formula. Can or not? Yep. You are silent, so I cannot hear whether you are alright or not.
Oh yeah, teacher.
Okay or not?
But when
Okay.
it says the Avogadro constant is
It's
like
given.
how
It's given in a data sheet. Yeah, the constant. Basically,
oh okay.
know where to find it.
Yeah.
Okay, if you are alright, no question. Let's go to equation of state. Right, that's what we are going to cover. Ideal gas. Memorize. Obey gas law and ideal gas equation at all temperature, pressure, and volume. Point mass is not attractive force. Right, this is given in their marking scheme. But many gases at room temperature and moderate pressure behave as ideal gas. Ideal gas behavior is based on experimental observation of gases such as air, helium, and nitrogen at temperature and pressure around room temperature. We don't want too high pressure. You try to squeeze the particles together so that the attractive force becomes significant. So we don't want that. That's the reason why we use at temperature and pressure around room temperature and atmospheric pressure. Okay, so that is the definition of whichever you prefer. Or gas obeying PV is proportional to T, where T is the thermodynamic temperature, is known as ideal gas. This from the syllabus. Right? Either one. Either from marking scheme or from your syllabus. Right? Memorize this formula. Ideal gas called ideal gas equation or equation of state. P is pressure of gas in container. V is volume of container. Small n is amount of substance in mole. R is molar gas constant. 8.314 joule per Kelvin per mole. This one is given in a data sheet. Absolute temperature. Usually we don't use 73.15. If you want, you can do that. It's just unnecessary because in this section, unless you are tested under temperature, then you have to use 273.15 lor. If not, usually we use 273, that's all. Right, so this formula you must know now how to use it. This number of molecules and K is Boltzmann constant, is R divided by Avogadro's constant. Right? This value is also given in your data sheet. Question. Real gas question. Real gas behave as ideal gas. When does a real gas behave as ideal gas? Pressure must be sufficiently low, about 1 atmosphere or less. Temperature must be sufficiently high, about 3 Kelvin. You don't want it to be near a melting point, you know. Melting point, the, the liquid is going to change to the solid. So we don't want that. Or we don't want near boiling point there lah. Right? So about 300 Kelvin, 300 Kelvin is 27 degrees Celsius there lah. About room temperature there lah. Okay. Right, this one is more for paper 5 lah. Review all your SPM work. Yes, law. How do gas behave if their pressure, volume, or temperature is changed? So normally we have pressure, volume, temperature. So we can investigate only 2 quantity at one time. Right? Variation of pressure with volume at constant temperature. Variation of pressure with temperature at constant volume. Or variation of volume with temperature at constant pressure. Right? These are the 3 things that we can do. So what are the variable or parameters? Volume of container, pressure of gas in a container, absolute temperature of gas, and number of molecules of gas. M is the mass of the gas particle. Right? We imagine there's a lot of particles of the gas in the container. So this PV equals nRT. N is the number of mole. This one together is the total mass. Total mass of gas. Right? We can use molecules or particles. P, V, P, and T, right? Volume, pressure, temperature are called macroscopic properties. Macroscopic because these are things where we can see and we can measure. To investigate variation of volume with pressure, right? This one they expect you to know the formula lah. Then you can rewrite the formula. Expected to rewrite the formula. And then identify where is the independent variable, 1 mark. Dependent variable, sometimes these two may be combined to give 1 mark lah. Right? You should be able to get this 9 mark lah. Paper 5. Keep the mass of trapped air constant, temperature constant. Right? You want to variation of volume and pressure. So we keep temperature and mass constant. How to find the volume? If it's in a container, right? Or in the apparatus, volume is just your length of air column. Measure, how do you measure it? Using meter rule. And then calculate with cross-sectional area. No? Then how do we display the result? Plot a graph of volume versus 1 over P. What type of graph we expect? A straight line graph passing to the origin. So this will be worth 1 or 2 mark. No? This one will be 1 or 2 mark. No? After each change in pressure, allow time for trapped air to return to room temperature. How to measure this pressure? Fordham gauge. How to measure the cross-sectional area A? Determine the internal diameter of the tube with vernier caliper. at different places and find the mean diameter. Right? This simple like that, how to calculate the radius, how to calculate the area, also worth 1 mark. Right? You must give them detail. That's the apparatus. Right? There's your trap air. There's your oil. Air is trapped in a glass tube. There's a glass tube. Compressed by forcing oil with a pump and taking reading of pressure and volume. After each compression, you should wait for a few moments to allow the temperature of air to stabilize. Right? When you compress it, the temperature is likely to change. That's why you have to leave it for time for the temperature to return to the surrounding temperature. The relationship between pressure and volume is discovered by Robert Boyle in 1660, and it's called Boyle's law. PV equals to constant. Safety precaution usually 1 or 2 only lah. 1 or 2 marks. Wear gloves when handling glass tube. Mop up any spilled oil. So Boyle's law, that's the graph. Right? The curve is called isothermal. And this one, the red one is at a higher temperature. T1 is greater than T2. Right? That's stated in Boyle's law lah. A fixed mass of gas with volume P1, pressure P1 and volume V1 changes to at constant temperature to a pressure P2, volume P2. So that's the equation. Pressure law. Pressure of a fixed mass of gas at constant volume is proportional to absolute temperature. Right? There's your pressure gauge or Borden gauge. Measure the pressure of air inside there. There's a water bath. Right? Water bath is for you to change the temperature by heating it with a Bunsen burner. Right? That's called the water bath. Keep the temperature constant. Water is heated and the pressure of the air in the sealed glass beaker or glass tube flask is measured with pressure gauge. The volume of air is effectively constant. Right? We neglect this volume there because this volume is too small. Result of the experiment show that the fixed mass of gas at constant volume, right? Constant volume, mass constant. So pressure equals to constant times temperature. Right? This is the idea of a constant volume gas thermometer. If a fixed mass of gas with pressure P1 and temperature T1 changes to pressure P2, temperature T2 with no change in volume, this can be written as P1 over T1 is P2 over T2. Measure of pressure and volume with temperature is shown as graph. Right? Pressure, temperature. So you extrapolate it, it should go to minus 273.15. Or if you use Kelvin, then you will start from 0. Investigating the variation of pressure with temperature. Right? All this you should know, because this you have learned before in your SPM or O level. Identify the independent variable. Dependent variable. Keep what is kept constant. Keep the mass of the trapped air constant, volume constant. How to measure pressure using Borden gauge or pressure gauge. On top of graph to plot a graph of pressure versus temperature, absolute temperature. What do you expect? A straight line passing through the origin. Each time, after each change in temperature, allow time for the trapped air to reach the temperature of the water bath. Right? You have to heat the water bath to change the temperature. You have to give it time for it to, so the temperature of air and the temperature of water bath to be the same. And how to measure temperature using a mercury thermometer graduated at 0.1 degrees Celsius. So you should be able to get about 8 marks there. And now to convert to Kelvin, right? Theta plus 273. Precaution: wear gloves when handling hot object. Care to be taken to avoid being scarred by hot water. To investigate, right? We are just repeating the same thing. Charles' law: volume is proportional to absolute temperature. Capillary tube has a small plug of concentric sulfuric acid placed in it, and it is then sealed at the other end. And basically, we have a tube there. There's a capillary tube. This part is open. This part is closed. And then this may be rubber band. No? And then the sulfuric acid, the oil to seal it, so that none of this trapped air can escape. It is most important that approximate safety precautions are taken when carrying out the experiment. You are dealing with water, you are dealing with glass, you have to wear gloves, handle it. Water in the beaker is heated, and length of the trapped air, that length there. Trapped air in the air column and temperature are both recorded. Result of the experiment show that the fixed mass of at constant pressure that's what you can show from your experiment. What's the purpose of concentrated sulfuric acid? Any idea?
No idea.
Act as a drying agent. Keep the air dry.
Oh.
Keep the trapped air dry. Okay, so you need to know a fixed mass of gas. If it has a volume V1 and then temperature T1, you change it to volume V2, temperature T2. With no change in pressure and volume and mass. That's the equation. No? A fixed mass of gas with constant volume V1 and temperature T1 changes to volume V2 and temperature T2 will not change. Sorry. No change in pressure. Let me know if I'm going too fast, because these are all your SPM work. No point going too slow.
Yeah.
Summarize that. If you are asked to paper 5, volume equals to K constant times T. Identify independent variable, dependent variable. Right? What to keep constant? Keep the mass of trapped air constant, pressure constant. That's atmospheric pressure. How to keep it constant? You just check once a while. Your barometer, check that the pressure is constant before you read, so that the pressure atmospheric pressure doesn't change that much. Length of air column using meter rule. What graph to plot? Graph of V against T, straight line passing through origin. After each change in temperature, allow time for the trapped air to reach the temperature. Remember, the glass and air is a poor conductor. That's why you need to give it time for it to reach the temperature of the water bath. And how to measure the independent variable T Using a thermometer graduated at 0.1 degrees Celsius, and how to calculate your T, theta plus 273.1581. Since you want it more accurate, you use 0.1 degrees Celsius, then this should be going to 0.15. Okay. So 1 mole of gas at constant is got 1 mole of gas. The 1 mole of gas, the constant is known as molar gas, R, molar gas constant. For n mole, we multiply by n. For n molecules, PV equals NKT. K is called Boltzmann constant equals to R over Na. Right? We obtain this equation by combining these three equations. Right? Boyle's law, Charles' law, and pressure law. Right? PV over T is a constant. So we get R. So we use 1 mole, then R is a molar gas constant. Okay, so let's summarize for you all this formula. Let's do number 3. Right? You are supposed to be able to calculate R. This one is given in the data sheet. Now the volume of 1 mole of ideal gas at standard temperature and pressure. Right? There's a standard pressure, atmospheric pressure. There's a room temperature. Standard pressure. There's a molar volume. Put it inside there and then calculate. Sorry. Okay, that's how we calculate our R. Okay. Derive PV equals NKT from ideal gas equation. PV equals nRT, where K is a Boltzmann constant equals to R over Na. How to do that? Try and have a go. Have a go first before I give you the answer. Right? PV is nRT. Derive this equation. PV is NKT. Can or not? We have 10 minutes left. Replace this one with N over Na. Then R over Na equals to K. Okay with that? Get our answer? Anything not clear?
Uh,
Yep.
Should be okay.
Okay, the rest you can try yourself. Let's try some partial question. Number 9. State what is meant by Avogadro's constant. Yep. Can or not?
Uh, no, got meaning on it.
Got lah.
Uh,
What's
I just remember
Avogadro's
the value.
constant?
6 point something times 10 to the power.
No,
Yeah.
number of atoms of carbon
Oh,
12,
okay.
right, in 0.1 or 12 gram of carbon 12. Lor. A balloon is filled with helium gas at pressure 1.1 times 10 to the power 10 to the power 5 Pascal at a temperature 25 degrees Celsius. The balloon has a volume of 6.5 times 10 to the power 4 cm cube. Helium may be assumed to be an ideal gas. Determine the number of gas atoms in the balloon. Okay, try that. Basically using the formula that I've given you, that's all. Right? We are just using this formula, that's all. Getting you to be familiarized with the formula. Right? Choose the right formula to use. Then easier to calculate. Put in your value. Right? That's the pressure. That's the volume. Right? We change it to meter cube and 10 to the power minus 6. And N, K from data sheet. And then this one, 25 plus 273, 298. Can or not? Anything not clear?
Okay.
Take what is meant by a mole. This is 2011 June, paper 42. Memory work only.
Molecule.
Amount of substance containing the same number of particle as 12 gram of carbon 12. Okay, solve the problem. Two containers A and B. You do no choice one. Definition, you have to score. Memory work. Two containers A and B are joined by a tube of negligible volume as illustrated. That volume is negligible. The containers are filled with ideal gas at pressure 2.3 times 10 to the power 5 Pascal. The gas in container A, that's the volume container A, the temperature. Right? Container B, that's the volume, that's the temperature. Calculate the total amount of gas in mole in a container. You should be able to do that. And what is the answer? PV equals to nRT. That's all. PV equals to nRT. Calculate your N. Right? Make sure you write the formula down. Don't just the formula out and show how you calculate total amount. Right? We take R out. R is common. The pressure is the same. That's the pressure. And volume is the one different. Volume 273 plus 17. Right? That's the volume. Right? You have to convert it to meter cube. 30 plus 273. Can or not? Anything not clear?
Okay.
will be cut off any time now lah. Still got about 3 minutes. Anything that's not clear? Remember to show your formula. Usually there's worth 1 mark. And you show your calculator. Any question? If not, let's carry on to 15.3.
Okay.
Right? That's the syllabus. Page 64. When we study about ideal gas equation, we are interested in macroscopic property of gas. Example would be pressure, volume, temperature that we can measure. It gives us a good description of gases in many different situations. Does not explain why gas behave this way. Right? Doesn't tell you why at constant temperature, volume is inversely proportional, pressure is inversely proportional to volume for Boyle's law. It doesn't explain why. It tell you there is a Boyle's law, that's all. Right? So we are, of course, interested to know more about that lah. So we come with kinetic theory. Kinetic theory of gases is a theory which links macroscopic property. Example, the particle inside the container got mass, velocity, and then relate it to macroscopic property of gas. On the basis of this assumption, it is possible to use Newton's Newtonian mechanics to show that the gas law, gas particle move with a range of speeds. To try to explain to us why Boyle's law, why pressure law. All matter is made of particles. Particles can be atoms, molecules, ions. Size of particle is 10 to the power minus 10 meter. Particles are in continuous motion. Right? This one is normal in the syllabus lah. The purpose of the experiment is to tell you that the air inside the air cell is moving at random lah. That's all. Okay, so you won't bother about all this lah. Right? Okay, assumptions. If you can remember PINED, P point mass, the volume of molecules, all these particles there, compare with the volume of container in negligible.